Hey all, after my last video I thought I'd look a bit deeper into the MaxiDrive low range gear set modifications and installation assembly processes. Thought I'd take you through a little bit of the case mods, which are pretty basic. It's just a matter of going slow, removing a little bit at a time, because you don't want to or need to take off more than you need to. So again, the low range gear is going to run in here, and being a bigger diameter, you just need to clearance the case a little bit. This is covered in the instructions pretty well, and it goes through the, you've got various ways. You can go in here with a small grinder and get in here and clean this up, and I've cleaned mine up a little bit more after that with a die grinder. It's just basically removing the high spots on these case ribs up here, where the low range output gear is going to run, and you will see that the underside of the bolt bosses is also removed. And again, it's just a matter of putting it in, checking the clearances, doing a little bit, checking it, doing a little bit, because you do not want to remove more than you have to. Allowing that little bit of clearance, and you do need a clearance, and it's only 1 millimeter or so, but you don't want it so tight that you're going to get friction build up. Like if it's only 0.2 of a mil or something, there's a good chance you'll get friction build up with the oil slinging around and whatnot, and heat and things like that. So you want a good millimeter of clearance around those things. Your bolt bosses and whatnot. So it's not a hell of a lot to do. It's just a matter of being a bit methodical about it, and I like to not just do the bare minimum and have sharp edges. I like to blend things out, less places for cracks to start, stress rises, whatnot. So that's the case, the basic case mods that you need to do for the gear sets themselves. Regarding the installation procedure that I went through, or the assembly procedure on the last video, when you read the instructions, it tells you to turn the case upside down, which would be like that, and put your gears in and stack through here, and put the center diff in through here. The problem with that is gravity's pushing down, and you're trying to align multiple parts with a concentric hole and then put a shaft through it. It is a real fiddle, and I find it awkward. I don't like doing it that way. And you have to turn the case over at the end anyway to push on the top bearing or the end bearing, which we've got to do that some way, somehow, no matter which way we choose to assemble it. So for me, having the case lay flat, obviously where I'm going to set it up on the bench, I've got a hole here to allow the center diff to drop through as much as it needs to. I'm going to heat the bearing up, and I've already heated it up to see if it's a slip fit here. It only needed to be about 55 degrees before it was enough to slip on. So my intention is to heat it up a little bit hotter, because it's going to lose heat in the time that it takes me. If I put the bearing in there and put the output gear, the high range output gear, the selector, high-low selector shaft and fork, the selector hub, put the ball gear in, all that takes time, and that heat's going to dissipate out to it. So I'm going to try and heat it up to about 75, 80 degrees. And so hopefully it's going to lose that little bit of heat, but still be hot enough that the center diff will just slide through. And then there's no need to figure out how we're going to flip the case over with all that stuff in there, but somewhat loose, and then put a sleeve over that, so we're only driving on the center of the bearing. So that's my intention, to do that method for assembly. Now, after you've assembled the gear set and the center diff, and you've got all that in the case, and you've got through that hurdle of the modified assembly, in the instructions it tells you the next procedure is to install the front output housing and its setup. The problem I have with that is in the case, we have on the rear output side, we have the bearing cup installed, and as per Land Rover's specifications, it's installed 1 millimetre below this working surface here. Now that's not actually the final install height or depth of this cup. That is determined by this spigot on the back of the rear output housing, because when you look at that, it's not flat and in line with this surface, and it's actually greater than 1 millimetre. So what they're doing is they're setting this bearing up at a starting depth that only requires another, maybe 0.5 millimetre fitment down, and that is created when you bolt this rear output housing down to the main case. You don't want to set it flush because, in my opinion, when you look at this is stiff through here, but the flange is not super stiff. So if you had to crush that bearing in, it may not pull all the way in, it may flex this or whatnot. So I think you set it down 1 mil, and then when you bolt this up, it pulls at that last little bit, and that's a fixed height or depth in relation to the case, in relation to the rear output housing. When you do your front output housing, which bolts on, funnily enough, the opposite side, the main centre diff taper roller bearing cup sits in here. What goes in here first before the cup is shims, and the shims determine the preload on the 2 taper roller bearings, one on the rear output end, one on the front output end. They are both fitted to the centre diff. This is the front output end, and this is the locking spline down in here, and then the bearing that we're going to have to install in the whole centre diff and output gear process is on the rear end. This one you already press on, that's fine, that's not an issue with regards to assembling the whole setup here in the case. To set your preload on these bearings, and this is assuming you've got your new gears, you're going to rebuild your case with new bearings, or if you mix and match cases or anything like this, the shims were set up from factory, the case is matched to the bearings, and as much as bearings are considered to be fairly consistent, if you're using the same brand, the same model number, they in reality just aren't exactly consistent, and you want to set your preload up pretty well. So to be able to do that, the rear output bearing has to be set at its final depth, again determined by the rear output housing being bolted to the case. So we need that, in my opinion, we need that installed. So once I install this gear set through here, and I'm happy I've got all that in, and the bearings are seated correctly, and that's ready to go, I'm not going to go forward to the front output housing. I'll install the rear output housing, make sure it's all tickety-boo, and then before I install anything in the front output housing, as opposed to the shafts and the output roller bearing and all that stuff that it says in the workshop manual, I will trial it with a shim and a dummy bearing, which again is just a dummy bearing cup. So that's a same brand, Timken, the right part number. I've just linished the outside so it's a slip fit, so I can remove it and change the shim. So I'll bolt that up dry. I will test the rolling resistance on the gear set until I'm happy with that shim. And even then, the dummy cup is a guide. It's not necessarily 100% accurate for the final brand new bearing cup. Even if it's same brand, same model, part number, it's just not a guaranteed. So, but if you haven't assembled everything else, then knocking this new cup out is not the end of the world. You'll see the passages here where you can come in from this side here and drift that cup out and change your shims as necessary. But once you've got that set and you've got your preload or rolling resistance set on your main center diff taper roller bearings, then you can go ahead and do the majority of the assembly on this as per the workshop manual and install it in that. But I think it's quite crucial to install this before the rear output housing, before the front output housing. That's my personal opinion. That's the way I'll be approaching it, given the factors. And there's a guy, Mike, Britannica Restorations on YouTube. A lot of you would have seen his stuff. He's got hundreds of videos on Land Rover information, a great resource and help for all of the Land Rover community. He's got a lot of videos on LT230 builds. I would suggest go and watch those builds to give you a really good look into the cases and all the different components and the builds, and see the little tips and tricks. I use a combination of his stuff and stuff I've learned, and as he does, I use a combination of the old original Land Rover workshop manual and the 300 sort of TDI generation workshop manual for these LT230s, and a bit of other sort of stuff. But if you watch those videos, you'll get a great understanding of the cases, how they work, and whatnot. But this is just a little bit different, given there's not a lot of stuff that I've seen for the MaxiDrive low range gear sets. And they do the 30% low, which is, this is essentially 4.3 to 1. And I'm the 49% low, which I think is about 5 to 1. It is a slightly bigger gear. The way they get away with it not being massively bigger is the tooth pitch is a little bit different, I believe. It used to be, I think it's still the way. So, but there's, again, additional instructions just for a little bit more clearance for the 49. Always read your instructions before you start. Take a good look at everything before you dive in, because you'd hate to wreck a case by going a little bit too far with your clearancing and whatnot. So at this stage, I'm going to do my final clean and prep on these, just because they've been sitting overnight, a little bit dusty, whatnot. And I'm going to get ready to install the center diff and gear set into the case, and I'll video that as well, and hopefully will work with the heating the bearing up, and it'll all just go together like a glove. That's the idea, and we'll see how we go with that. And if you get the opportunity and you're going to do a few of these cases, you might choose to make a few special tools to make it easier. And I was fortunate enough to have a friend let me use his lathe and help me out, and we made some special tools just for pressing bearings and removing bearings. Like this one here is for this particular bearing cup, which is the rear output bearing, and you'll just see that slight little shoulder there, which is 1 mil, which allows us just to press that in and have that seated at 1 mil. And the other end is actually for removing them on used cases. We come in from the inside and use this side and push the bearing out. This little one here is for doing that bearing down there, which is the input bearing. That'll locate down in that bearing and seats that nicely. And I can also use that on the rear bearing support plate, which is actually this end here, which has the identical bearing on this end for the input gear. So you don't have to make those things. You can use sockets, you can use pipe, just deburr stuff and make sure the ends are square. There's a lot of ways of doing it. You can use heat to help with bearings. You can use either on the bearing or on the housings. Even Land Rover recommend heating these up to 100 degrees and the bearings just drop in. You don't even need 100 degrees. 60 degrees is probably enough. You can do that with an electric heat gun. Bearings you can shrink in the fridge or the freezer enough to help you to drop in as well. I used to do that. I'm not so much a fan because of condensation. It always builds up. It's probably a non-issue. I just don't like it. The biggest thing with heat, and everything's got a compromise or its pluses and minuses. When you're heating stuff, is try and heat it uniformly. You don't want to just have one spot hot and one spot cold. It's not great for certain parts. So hopefully that's a bit of a help with the case prep and, going through the idea of assembling them in a certain order for various reasons. At the end of the day, you've got to do what you guys want to do and what makes you sort of think you're going along the right way, which is all good. And, so the next thing I'll do is try and assemble the gear set in the case using the heat, and hopefully it just drops together, and we'll see how we go with that. All right, I've got all the case ready, all the components cleaned and oiled up, ready to go. Unfortunately, heat does not work with the bearing. Heated up to 75 degrees. I didn't want to get it any hotter than that. We've seen recordings with oil temperature gauges that these get up to 100 degrees in Australia, but I don't think I want to heat a bearing up any more than 75 degrees. That's plenty, especially new bearings. So what happened was, installed it, it just dissipates the heat way too quickly and the center diff doesn't drop through, so it's of no real advantage. So I don't see any point putting heat into the bearing when it's not going to achieve anything positive. So I'm going to have to install it all, and then in the MaxiDrive instructions it says to find a drift and turn the case over and drift it in. That's just a tool I made for removing Disco 1 Rotaflex pinion flanders off the diffs. It just happens to be a good fit for that. It's just a bit of normal bore pipe, the cap welded on. I'm going to press it in the press rather than belting it around. So assembly will be the same, just a matter of installing everything, and then we'll have to take it over to the press and press it. So we'll see how all this goes. This is just Castrol Syntrax 75W90, a full synthetic oil. We won't get into oils. Everyone runs what they think's the best and everything else is crap. But at the end of the day, only run a good quality gear oil with the right specifications in it, whatever flavour. And I would suggest you do not go over 20,000 Ks as the service intervals. A friend of mine who is right into oils and done a lot of oil analysis has seen the best Motul gear oils and synthetic oils fall away. So it's just not worth the life of the case and the bearings and everything, especially if you go into the good componentry, and if you're running more horsepower or whatever, do not go over 20,000 Ks. They just can't handle it. As the center diff will go at this stage. So just for assembly and making sure it wasn't going to foul anything, I had it on a small block of wood, 18-19 millimeters thick, and I actually had an old bearing cup, exact same as the rear output side main center diff taper roller bearing. The bearing cup, I just turned it over and set it up exactly under the new cup that's in the case, just to support it with that timber there. It gives us some clearance just to make sure everything's pretty good. So that's all pretty good. I'll have to turn it over, set it on the press table, and use this to press down on the bearing and that. So the case is just floating, everything else is floating, and all we're doing is pressing the center of the bearing down as we would normally, this part, but on the other bearing, down over the center diff shaft. We'll see how that goes. For doing it this way, we shouldn't be pushing on anything other than bearing and the part of the bearing that's okay to press on, and straight through the centre diff shaft, through the centre of the centre diff. Everything else should be roses. Make sure we're going on through. Yep, that's looking pretty parallel. There we go. Starting to read a tiny bit on the pressure gauge. We'll just give it a little bit to make sure it's seated, not too much. That's plenty. Maybe 1.5 tonne, if that. Everything else seems fine. We'll be able to put our big end nut on, do it to torque. We'll just check everything's okay there. Okay, so I've just brought the case back over the bench before I go anywhere near doing the big stake nut up. First thing is to check everything, check that it rotates freely, nothing's binding, nothing's rubbing. We want to go through, and because with these, unfortunately, you can't see visually that the bearing is seated all the way home. And if you remember from the assembly process of the standard setup where you can do it all together out on the bench, the low range output gear or MaxiDrive bull gear seats against the centre diff shoulder. Then you've got your high-low hub that engages on the splines on the centre diff. That is hard down to a shoulder, and then there's the end float between the gear and the hub, and then the high range output gear with its bush is seated hard down. The bush is against the shoulder, another shoulder on the centre diff, and the bush length determines the float on the high range output gear, and the bearing is pressed hard against the high range output gear bush. So you've got gear, hub, gear with bush and bearing all pushed down hard by the bearing and then retained by the big flat nut that we do up on the other end. So if the bearing's not seated properly, your float's not going to be to spec. And you can't visually see that given how it's installed now. So all you can do is go by feel and by check. So first things, make sure everything engages and does what it does. At the moment, that's in high range. I can spin the low range gear freely as it should. Feels smooth, nothing's catching. I'm also considering double checking myself with the case. Nothing's grabbing on the case. High range gear is engaged. Just by pulling the high-low selector shaft up, I will just pull it up into neutral, and I'll make sure by resting and stopping the centre diff from spinning, the high range output gear can spin freely. Engage it all the way up, engage low range, make sure that engages and turns. And the other thing, give your gears a wiggle to feel that float. Now the end float's so small, it's hard to feel, but what you don't want to feel is sloppy. Like, oh geez, rattle, 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 that it wasn't when you did your pre-assembly inspection and check of floats out on the bench, because we know it shouldn't be like that, and the bearing won't be seated. But that all feels good. That's got free again, no wiggle wiggle. So that's it, and that's one way, my way of installing your MaxiDrive low range gear set on your centre diff, assembling it into the housing. Hope that helps. Cheers.